Measures of dispersion, or measures of spread, help us understand how dispersed or spread out our data is, which in turn lets us know how meaningful our mean is. Put another way, how far a random result is likely to fall from the mean. If our data is widely spread, a result far from the mean becomes more likely. When making inferences, this can mean more uncertainty. The simplest measures of dispersion are the minimum, maximum, and range, or the smallest value, largest value, and distance between them. The minimum, maximum, and range help us understand the best and worst case scenarios. When looking at a Monte Carlo simulation, the minimum would be the most we are expecting to lose, and the maximum is our greatest expected gain. And the range would describe the entire spectrum of possibilities. Quartiles are another way of dividing distributions. Whereas median is just the middle of our data, quartiles take the middles of that middle, dividing our data set into 4 quarters. This method is popular with economists who use quartiles to study policy effects at different income levels. By looking at changes in income across the first, second, third, and fourth quartiles, they can provide a more nuanced picture of a changing economy, which speaks to the experiences at each quartile. Variance is a measure of how spread out all our data points are. A high variance suggests a high volatility, while a low variance suggests a low volatility. This measure is quite popular with investors who use it to describe the risk of certain investments. Accountants will also use variance to describe how much a budget item may be expected to swing month to month. By comparing past budgets to actuals, we can quantify the variance of particular budget items. Standard deviation is our last measure of spread. It's very commonly used in statistics. The standard deviation describes the average distance we expect an individual data point or sample to fall from the mean. It is often abbreviated as SD, or the Greek letter sigma. When our data is normally distributed, standard deviation easily helps us understand the likelihood of data falling inside or outside a specific range. This is because 68% of data falls within one standard deviation, 95% of data falls within 2 standard deviations, and 99.7% of data falls within 3 standard deviations. This is known as the 68-95-99.7 rule, or the empirical rule. So imagine we had a bucket of gala apples, and we knew that the mean weight of these apples was 200 grams. With a standard deviation of 12 grams, if we pick an apple out of our bucket, that would mean it has a 68% chance of being within 188 and 212 grams. It also means that we have only a 2.5% chance of pulling out an apple that is more than 236 grams. We'll come back to this idea as we get more into inferential statistics. For now, let's take a closer look at how variance and standard deviation are calculated.